All right, so good evening, everyone. We're on week 18, day two. We're yesterday you guys learned about SageMaker. We're continuing on with that throughout this whole week with SageMaker integrations. So we have one lesson, one lab, one challenge, and then we have our TLOs and ELOs, as well as a glossary of key terms. So week 18, day two teaches you to wrap SageMaker endpoints and fast API services, add production-ready error handling, and integrate with LangChain as tools. You'll learn how machine learning models fit into larger application architectures. By the end of today, you'll have built a fast API service that wraps your week 17, day three XGBoost endpoint, handles errors gracefully, and integrates with LangChain agents. You'll understand how production APIs abstract machine learning endpoints and how AI agents can call your models. So what are we trying to accomplish? You know how to deploy SageMaker endpoints. You know how to invoke them with Boto3, but in production, you don't call endpoints directly from applications. You wrap them in APIs that handle errors, validate input, and integrate with other services. Today, you're building that layer, the fast API service that sits between your application and your machine learning models. You'll also learn how to make your endpoints available to LangChain agents, enabling AI systems to call your models as tools. So let's quickly take a look at our glossary of key terms. So FastAPI, a modern Python web framework for building APIs with automatic documentation and type validation. API wrapper, a service layer that abstracts underlying services, so like SageMaker endpoints behind a standardized interface. Cold start is the delay when a SageMaker endpoint first receives a request after being idle as it initializes the model. Exponential backoff, a retry strategy where wait times increase exponentially between retry attempts. You guys know about LangChain tool. So it's a function that LangChain agents can call to interact with external systems or services. Pydantic model, a data validation class that ensures request/response data matches expected structure and types. Remember, it's kind of just like a blueprint. Request validation, checking that incoming API requests contain valid data before processing. And then agent. So as you guys know, an AI system that can use tools to accomplish tasks, making decisions about which tools to call and when. So are there any questions before we get into the lesson? All right. So fast API integration with SageMaker. Overview. So we know how to we know how to deploy SageMaker endpoints, invoke them with Boto3, but that's not what you're going to do in production applications. We have to wrap them in APIs. So let's get into a little bit of the difference between the endpoint versus the API. So endpoint is the thing that runs the model. API is just the thing that other systems talk to. So kind of think when I picture, I kind of think about like a tunnel. So the tunnel to a city would be uh an endpoint, and then those roads right before that tunnel is what I think of as an API. So another way to think about it is endpoints are built for AWS, but APIs are built for everything else, all the other applications. So you would use an endpoint, for example, if you want to integrate S lambdas to with SageMaker. So it's just being able to communicate more so between AWS. I mean, that's not the only way you can use it. You can also, of course, as you guys have experience with from last week, you can invoke it through applications. But just kind of think about it that way. You kind of want to use endpoints for more. You have to be more careful when you're using endpoints because it can disclose your AWS credentials because whenever you need to invoke one, you need that. But API kind of just builds an armor around it so that you're safe and uh all that what was mentioned is mitigated. So again, calling an endpoint works, but it's not the best practice. It becomes a problem in production because every app will need to know the endpoint name, know the AWS credentials, and every app needs to handle AWS errors and etc. If one small thing changes, then everything around it could break. So just again, just think about the safety when comparing the two. APIs just puts that armor around the endpoint. So why wrap endpoint? So everything I just said, we're pretty much going to get into it in the lesson. So wire wrap endpoints and APIs is for direct end direct endpoint calls are the problem. So when you call a SageMaker endpoint directly, you're tightly coupled to AWS. So your code would look something like this. You set your runtime using Bodo 3. You're using SageMaker as the client, and then we're setting a bunch of parameters for response. So after we invoke the endpoint with our runtime, we also have to provide the endpoint name, the content type, and then the body. The body is just the features. So this works, but has problems. So there's no error handling, no validation. It's tightly coupled, and there's no abstraction. So for no error handling, what if the endpoint is cold? What if it times out? No validation. What if the input is malformed? Tight coupling. Your application code knows about SageMaker specifics. And then no abstraction. Other services can't easily call your model. So the solution is using an API wrapper. So a fast API service wraps your endpoint behind a clean interface. So here we have a post method to this uh, URL. So / predict. And then we have our features in a nicely formatted object. And then instead of, as you can see up here in the body, everything was within a comma and just separate, and everything was within a apostrophe and separated by commas. Over here, we actually have a list. And then for our response, we're actually formatting it to say we want a prediction and a confidence, and then we just have some placeholders. So 0.87 and then high. So what are the benefits? We have error handling, validation, abstraction, integration, and documentation. So for error handling, the API handles cold starts, timeouts, retries. We'll see that in the later examples. Validation, Pydantic models ensure valid input. So you guys have used that before. It's one of these classes that just kind of uh, give you your blueprint. And then we have abstraction. Your application doesn't know about SageMaker. So if the app is compromised, your AWS account is exposed. So attackers can invoke the endpoints, run up costs, probe model behavior, and etc. So that's why we use APIs. Integration. So with APIs, we can integrate web apps, mobile apps, and other services can call it. And then we also have documentation, FastAPI, auto-generates API docs. In production, this is how it would work. Your machine learning models live behind APIs. So FastAPI basics for SageMaker, creating a route. So FastAPI routes are Python functions decorated with HTTP methods. Does anybody kind of see a resemblance of this code snippet to something else?
What in what way? Like that's how we normally do it, right? We route to a function.
Yeah, yeah. So yeah, what else have you guys been using that has the routes and then a function underneath?
Um,
Flask?
Flask?
Yep. Yep. Yeah, when I look at this, I kind of just think about how it's kind of similar to Flask. So you initialize your application. Over here, we're initializing it to FastAPI after our imports. And then instead of app.root, and then you have your method, so post, get, and then your URL endpoint. Instead of having that, we actually have the method appended to app. So app.post, app.get. The other way I was mentioning is what you would do in Flask. So over here, that's why I kind of see a resemblance. So we specify that for this function, we want a post method, and then that occurs when we reach this URL endpoint. So our function is called predict, and we just pass in a list of float. So this saying the format for our features must be a list and be floats. And then we just have a placeholder for what we return, which is a prediction of 0.87. So the decorator app.post creates a post endpoint. Fast API automatically validates the request body against the type hints. So let's look at request response models with Pydantic. Pydantic models define your API contract. So we have our imports, and then we have our classes. Uh, so again, these two are kind of just like your blueprints of what the format should be. So when sending a request, it should have this format. So the features again must be a list and must be floats. And then the minimum confidence float equals 0.5. So that means a uh, if a prediction gets returned that is less than 0.5, it will return the confidence as low. And then prediction response, it must be in this format. So prediction must be a float, confidence must be a string, and model version must be a string. So let's go back up to this minimum confidence. So this is not, uh, it's optional to put in. So you're just kind of setting the default for it. Any questions so far? All right. And then, so we created our classes or blueprints. So now we have to use them in our root. So here we have a dot post method again. And then we have / predict. And then for the response model, we want it to be in this format. So we put it over here. And then within the actual function, we have the function name, so predict, and then request. We want our request to be formatted in this way. So request that features validated, and then again, the minimum confidence defaults to 0.5, and we get returned this placeholder again. So if we look, we see that the prediction response class has the same format as what we're returning. So the prediction is a float, confidence is a string, and then model version is also a string. Fast API validates incoming requests against the model. Invalid requests return 422 errors automatically. So calling SageMaker endpoints inside our root, we call SageMaker via Boto3. So we have our imports. We initialize our runtime, and then again we have our decorator. So app.post / predict. We have our function. So over here again, we want our request to be in the same format as prediction request. We format the input for SageMaker. So we have our data, and we're just joining with commas. And then we actually call and invoke our endpoint. So again, to invoke our endpoint, we need our endpoint name, the content type, we're using CSV. And then we're just passing in this formatted data into the body. And we just return, we so we set the variable result for a uh, for JSON that gets the response in the body, and then we return the prediction. Uh, we return the prediction. So this is the core pattern: receive request, format for SageMaker, call endpoint, and then you format the response, which is what this is doing. So error handling, we have a bunch. Again, APIs can do that, but endpoints can't. So for error handling, we have cold starts, timeouts, invalid input, retry logic. So let's take a look at cold starts. When a SageMaker endpoint hasn't received requests in a while, the first request is slow. The model container needs to initialize. So the problem, the first request after idle time takes 10 or 30 seconds instead of milliseconds. Our solution, detect the cold starts and handle them. So we have a function called call endpoint with retry. We pass in our endpoint name, our data or features, and then we set the max retries to 3. So for each attempt or retry, we're going to try this block of code. So this block of code is pretty much saying start the timer. So it's getting the time from when it first runs, and then you're subtracting that from the end time, which you will get the elapsed variable. And we're setting the variable response to again invoke our endpoint with endpoint name, content type, and body. So if it takes more than 5 seconds and it hasn't reached the max retries yet, it will briefly wait before retrying, and then it will eventually continue to return your response. And then we also have an error handling down here. Timeouts. So uh, this decorator right here, context manager, is just a shortcut. It's a shortcut, so we don't have to write a full class on uh, handling the different times. So it kind of just does everything for us. You guys don't really need to know this. Just going over more details. Function, we have a timeout function, and then we pass in our seconds. And actually, let's do it backwards. So we have our post method over here, and then / predict. So we have our predict function, which we pass in our prediction request class. And then we're trying with timeout of 30 seconds. So it's calling this function. Uh, we're trying to invoke that endpoint. So it calls this timeout function. And then within there, there's also a timeout handler. And it's just up here in the beginning of the function because we need to set it in place so that uh, it can be called when there is a signal. So over here, you see signal.alarm seconds. So we pass in that 30 seconds, and after 30 seconds, it'll send an alarm to this line right here, which will call that function. So if it's past that 30 seconds, it'll give you a timeout error. So operation timed out after 30 seconds. So that's what this is doing. Invalid input. So we have a validator decorator as well as our class blueprint. So we have our prediction request, and then our features has to be a list of floats. So over here within our function, within our validate features function, we have CLS. CLS just it stands for class. So kind of think about it as a self. So whenever you create a class, you would sometimes initialize self. So just think about it like that. And then V is for so for each feature. So one feature at a time. And then uh uh, or actually V is the whole list of features, and then F is the one feature. So uh this is saying if the length of the features is anything other than 5, spit out this error. So it must provide exactly 5 features. And then this is saying if uh if any of the individual features within that list is less than 0 or over 100, uh give out this error. Features must be between 0 and 100. And then yeah, it'll just return the whole list. So that's another thing for error handling, invalid input. Just make sure everything is good to go. So Pydantic automatically returns 422 errors with validation failures. Next up is retry logic. So retry logic with exponential backoff. When endpoints fail temporarily, retry with increasing delays. So uh, we have a function called call with backoff. We pass in our endpoint name, data, and then max retries. And then for each retry, we invoke our endpoint with a name, content type, and body. And then we also have an exception. Uh, so this is for error handling. And then down here, we have exponential backoff with jitter. So this is pretty much saying it's the time in between each retries is what this is handling. So uh, as you see here and in this part, it says to star star attempt. So uh, if it's the first attempt, it's pretty much saying 2 to the power of 1. And then if it's the second attempt, it's 2 to the power of 2. So third attempt, 2 to the power of 3. So in that way, it always just doubles the wait time. It is what this is doing. So it goes from 2 seconds to 4 seconds to 8 seconds, or 1, 2, and 4. But as long as you get that it doubles, and that's what it's doing, you're good to go. So LangChain integration, LangChain agents can use tools to accomplish tasks. You guys have used LangChain tools previously, so just kind of quickly go over this. Your SageMaker endpoints can be tools. So what are LangChain tools? A tool is a function that an agent can call. The agent decides when to call it based on the task. An example, an agent needs to check if a transaction is fraudulent. It calls your fraud detection tool. So wrapping fast API endpoints as tools, create a tool that calls your fast API endpoint. And one thing to note here that this is using uh, an older version of LangChain, so that's why the tooling is set up right here. The newer versions of LangChain, you just use that tool decorator on top of the function. So we have our function fraud detection tool. So we're passing in our transaction data, should be a string. So we set our response variable to equal requests.post to this endpoint, and then uh, with this JSON variable, we're just parsing through that data that we passed in. We have our result, so we're just getting the response from that JSON that we get returned, and then we're returning the fraud probability from the result in the predictions section. So We also have our tool. So the name of our tool is fraud detection function. We're just calling that fraud detection tool. And we just have a quick description. Checks if a financial transaction is fraudulent. Input transaction details as JSON string. So the tool description tells the agent when to use it. The agent reads the description and decides if the tool is relevant. Using tools and agents. So we're just initializing our LLM, initializing our agent, and then we our agent can now use the tool. So we have our response. With the agent, we run, is this transaction fraudulent? Amount $5,000 and the merchant unknown. The agent decides to call your tool, get the result, and use it to answer the question. Now, why does this matter? When you wrap machine learning endpoints as LangChain tools, AI agents can call your models intelligently, combine multiple tools, and handle complex workflows. This is how production AI systems work. Agents orchestrate specialized tools, including your machine learning models. So just different best practices or production patterns. So don't hard code endpoint names, log requests and responses, and then of course add a health check endpoint just to make sure everything is running. Key takeaways for our lesson is API wrappers, abstract machine learning endpoints behind clean interfaces, FastAPI provide automatic validation, documentation, and type safety. Error handling is critical. So cold starts, timeouts, retries, pydantic models, validate requests, and define API contracts. LangChain tools and production APIs need logging, health checks, and configuration management. Are there any questions with the lesson? So again, we just wrap our endpoints in that in an API. So we're using FastAPI so that we can handle errors, validation, abstraction, and then we can also auto-generate some documentation, which we will see in the lab. There's no questions. Let's go ahead and get started with the lab. All right. Our lab build a fast API service with LangChain integration. Objectives: by completing this lab, you will set up a fast API development environment, create a basic fast API service with a /predict route, integrate the service with your week 17 day 3 SageMaker endpoint, add error handling for cold starts and timeouts, implement request validation with pydantic models, wrap the endpoint as a LangChain tool, create a LangChain agent that uses that tool, and then test the complete integration. For our real-world context, at companies like Stripe or Square, machine learning models don't live in isolation. They're wrapped in APIs that web applications call. When a customer makes a transaction, the app calls your fraud detection API, not the SageMaker endpoint directly. Today, you're building that production layer, the API that abstracts your machine learning models and makes them accessible to other services. So prerequisites, day three, our day three lab deployed and running, Python, among other things. All right, let's get started with part one. Let me pull this up on my other screen. All right, so I don't have my model deployed yet. So I'm going back to my week 17, day three lab from last week. And I'm going to go ahead and train my model and then deploy it to have the model artifact in the S3 bucket. So let me just do AWS configure list to make sure that my CLI is pointing to the correct destination. So it is. And then now I'm going to run my my train xgboost.py file. Any questions so far? Can someone tell me the difference between an API and the endpoint? Wait.
In this context,
Yep, in this context.
the endpoint is the raw endpoint for the SageMaker uh, model access versus the API is a layer on top of that to prevent direct API access and do error handling and maybe even authentication on top of that without letting the end user access or knowledge of the underlying model and all that.
Yep. So uh one thing to think about too is so the fast API, what we're using is going to be held in the back end, but if you're just invoking the endpoint, usually you're doing that from the front end. So that way it'll your configuration is more exposed that way. So I also kind of I don't know if this is the right way to think about it. I kind of think about the endpoint as the doorway to our model. So you can just quickly go in there and see everything about it. And then an API would be anybody have a good example for an API?
Mm,
I mean, that is what allows us to interact with the endpoint, right? The interfacing at that layer. So your analogy is good. We enter into a building. Janitor has these keys, right? These keys that unlock certain doors. That would be the API. I think if we go in that direction, is that right or no?
Yeah, I think that's right. Another when you were saying that too, I came up with another idea. So maybe the API is also just like the maybe the so if you don't have the API, the endpoint is fairly close, and you can reach out your hand, grab that doorknob, and then open that door. But if you put an API in between, maybe you're adding uh like a road. So you're going to be further away from the endpoint. Maybe it's multiple roads with different turns. So you're still connected to that endpoint, but it's more work to get to it.
Mm. Because that layer, like when we think about sites and
Mhm.
the requests that are made, right? Get requests, post requests, right?
Mhm.
Those are the application interfaces, right? How we're interfacing with it. We we just put a button on it that'll have a different name, but you know.
well, and keeping with your analogy, an API would actually just be the address to the apartment, wouldn't it? And maybe some directions to how to get to the apartment.
I would say maybe the directions is the API, and then the actual address is the endpoint. The,
Correct.
yeah.
Which I guess we would say the node or the communication node to where the API would reference to, or maybe subscribe to, depending on what kind of communication pattern we're talking about or protocol. Because there's also API specification and documentation too.
Mhm.
which I mean, again, same thing. Tells it, gives it all the information, address to where to find it, how to talk to that particular endpoint or communication node. I mean, because if a communication node is speaking on Swahili and our API is speaking, I don't know, Latin, then they don't know how to talk to each other.
Sure.
Yep, yep. I think we all got a good grasp on it. Everybody, what everybody was saying, is true and correct. So let's continue on with the lab. So the process just finished, and we have trained our model artifact, and it can be found within our S3 bucket. So we just got to make sure, since I already had a model artifact over there, I just have to make sure of what just got created. So it ends in 723. So we have our 723 over here. I'm just going to delete this other one because I don't have a need for it. All right. So now I'm actually going to run my deploy model.py so that I can create endpoints and the endpoint configurations. We're just gonna get the job name. Is this the correct one? Nope, it's this one right here. Is that the same? Yeah. So our endpoint config got created. This is the name. And then our actual endpoint got created as well for our model. And here's the name. How's everybody doing? Everybody following along so far? If you have any questions, just shout them out while we wait for this.
Can we, since we're all on the same account, just use your endpoints and models?
Mm, yeah, yeah, I'm pretty sure you can. Yeah.
Yeah, but I'm not sure that'd be a good idea. Because I mean, when you were going reviewing everything, I saw one of the clip notes you were talking about the what was it called, the herd something problem.
Just implement the jitter.
Oh yeah, yeah.
Yeah, you'd have to. Which are you
I can't
implementing
imagine
that?
we're going to be hitting it often enough to actually make it stress, though.
Oh, although I know, I mean, depending on what kind of data we can be sending to. Like, is it gonna be a batch data or just basically streaming it?
So for the lab,
Batch
we
stream.
just have a bunch of test data, so pretty much a bunch of zeros, but at the end I will show you guys what we get back from our validation CSV so that we can actually get something other than what is expected out of the lab. So we'll do that too. Just test it out. Yeah, usually I only get 3 status updates, then it'll be done. We got 6 today, so let's see how much we get, how many we get.
This is a little awkward. It's like everybody's in a room and somebody farted, but nobody wants to acknowledge it.
Who forwarded? All right, we have our endpoint. So let's go back to our lab. Just let's verify our endpoint exists. So I'm going to run this in the terminal. So we're just listing the endpoints in SageMaker. So 157, 157. All right, got it. It's also verifying the console. Let's see. I always miss that inference. Oh, there it is. All right. So our endpoint is in service. So let's actually going to make a directory called lab, cd into it, and then I'm just going to create a virtual environment real quick. Going to open up VS Code. And then going to activate my virtual environment. All right. So after I activated my virtual environment, I'm going to export my endpoint name just so that it is within the environment of the shell.
Is there any reason to export it from the terminal versus making a .env file and sourcing it from there?
Uh, Mainly just from the commands we're going to be running through the lab. There's it's just it's able to get that variable quicker compared to like if it was stored in a .env file. Because I was thinking about that when I went through this at first as well. But yeah, we're just storing the all the different variables within the terminal because we're going to be running a bunch of commands that utilize them,
Okay.
which we will also see right after this one. So let's set our endpoint name. I guess this is not a good example, but over here we're just looking for that endpoint we just specified and just getting the details about it. So what we're looking for here is that it's in service, which it is. So let's press Q to go back to our terminal. And then let's install our dependencies. So we're just putting these dependencies within our requirements.txt file. And then we're actually going to install it now using pip install -r requirements.txt. Let's upgrade our pip. See, I don't know why I get this once in a while, even when I'm in my virtual environment. But let's keep going. This command here is just checking to see if all the packages got installed. If it is, it'll print out this statement. So the dependencies it was looking at is FastAPI, LangChain, and Boto3. So we got the desired output, so we're good to go. Let's move on. Part 3, we're creating a basic FastAPI service that has a health check and a predict route. So we have our imports. We'll come back to this later. Actually, hold on, I need to look up the short key to because I feel like this is underlined right here because the shell is not, or the VS Code is not being linked to my virtual environment. So let me take a look at that real quick. All right, so what I did over here was I pressed Command Shift P, and then you just have to look for Python select interpreter. Chose that, and then I chose my virtual environment. Enough. So it took away the underlines. So let's see if it will work. It should. All right, so we initialize our app with Fast API, and then we include the title. So we set it as SageMaker Fraud Detection API. We create our Pydantic model, so the prediction request and then prediction response. We have two routes, health /health and then /predict. One just checks if it's healthy, and then one right now is just returning a placeholder response. So notice that predict has a dot post method, and then the / health has a dot get method. So let's start our development server. So just put in this command unicorn app reload port 8000. The reload flag just auto restarts the server when you change the code. So if we modify our app.py, it will automatically refresh. So let's check. Let's test the endpoint. So I'm going to start a new terminal, and then using the curl command, uh, using the post method, sending it to the local host at port 8000 / predict, and passing in some features. So let's see what we get. So it worked. So we got the prediction of 0.5 and the confidence of medium. Let's actually go to our local host. So it is working. We see our two roots. So / health and then / predict. Next, we're going to integrate SageMaker endpoint into our app.py. So we have our imports, initialize the app. We get our endpoint name. We have and Nick, like you were saying, we could just have a .env file. It's really up to you which one you want to do. We have our runtime client, and then Pydantic models, our two roots, health and predict. We modified the / predict to include the response model. So we want it in the prediction response format. So we want a prediction and a confidence. And then we have our CSV data. We're invoking the endpoint. We parse the response. And then we're just determining the confidence level. So if it is above 0.7, it'll be high. And then if it's anything above 0.3, but still below 0.7, it will be medium. Anything below 0.3 will be low. And then we return that prediction. So this is the same as what we did in week 17, day 2, but the difference is it's now inside a FastAPI route. So right here. So let's set our endpoint name. Did we just do that? But let's do it again. Actually, we have to do it again because we're in a new terminal now, new shell. So before we did it in this first shell, now we since our first shell is running that server, we now have to create it in the second shell that we're running commands from. So let's restart the server just in case. It should already be updating on its own. Again, because of that reload flag. Yep. So it's already in use, so we're good. Let's test the integration. So we just have some test features, all bunch of zeros. Internal server error. Let's see what we float object line 38. Okay, so the the issue here is that app.py is trying to parse a JSON with a predictions key, but our XGBoost endpoint returns a raw float. So we have to replace uh this right here. Wait, actually, let's try replacing this parse response with this. Let's see if it works. Let's try to run this back again.
Would you print the result and then run it just to see what it is?
Mm.
Just under, no, just under line 37. Is that it up there? Fourth line from the top? Uh, yeah,
Yeah,
that.
yeah, yep. Yeah, what I'm trying to figure, because I know this error was gonna eventually pop up in the lab, but I don't know why when I try to change the this right here, it was giving me that red underline.
Hover over the red underline. Does it give you any clue?
Yeah, it says
Oh,
about
yeah. Yeah,
tab.
it's the white space is weird. So when you copy and pasted it in, it's probably
Mhm.
got like a mix of tabs and spaces or something.
Oh, okay, okay.
Yeah. I hate it when it does that.
All right, let's try it. All right, cool. We got something back. Let's go. All right. So yeah, the reason why that occurred was a mismatch of formats. So app.py originally was trying to parse a JSON with a with a prediction key, but our XGBoost endpoint returns a float as we saw when we printed it out. So all right, let's continue on with the lab. So now let's add error handling. Uh, this is getting created in a new Python file called app part one. To be honest, I don't know why this is in the lab because it doesn't get called, but I do see a point in it because it's just showing uh more in depth on the health endpoint or health checkpoint. So we have our root / health. So it just checks if the SageMaker endpoint is available and in service. So we have our it just checks if yeah. So we have our client, which is SageMaker in the region US East 1. We have our endpoint info. So we're passing in our endpoint name, the status. So if it's in service, it returns healthy. But if it returns anything else besides in service, it's not good to go. It's unhealthy. And then we also have uh error handler if this try doesn't work. So now let's look at the retry function, which we saw earlier. So it's just when it first attempts, is going to create a start time and eventually a final time, which you will get the elapsed. It's invoking our endpoint using the endpoint name, content type, and body. And then we're using a CSV as our data. And we have some conditionals. If the response took more than 5 seconds, it might be a cold start. So we'll retry once to ensure endpoint is warm. And then we have some error handling down here as well. So combining everything in app.py. So again, we have our imports, we have our app, we initialize it with FastAPI, endpoint name, our runtime client, Pydantic models, our roots, so / health. We see what we just saw in part one, app part one.py with the healthy, unhealthy statuses. And then we have our retry handler for retry logic for cold starts, which we also saw from app part 2.py. We have our error handling. And then for our app.post / predict, so we're just validating if the feature count is uh, anything other than 29, or if it is 29, because 29 features is expected with our test data. Later on, when we try out week 17 day threes, we're gonna have to change these to 30 because that's what we will be working with. So we'll go back to that later. So we call this function call endpoint with retry, pass in our features, we parse the response, And then we're handling different response formats. We might run into that error again. So we might have to switch this out. And then we're determining the confidence with some conditionals. If it's greater than 0.7, it's high. If it's between 0.7 and 0.3, it's medium. Anything below 0.3 is low. And then we return our prediction using that prediction response identic model with prediction and confidence. And then we have some more error handling down here. So as you see, the complete app combines the health check, retry logic, and then the predict route. The retry function handles cold starts, and the predict route validates input and formats the response. So let's test the error handling with invalid input. So we have our content type, application/JSON, and our features 1.0 and 2.0. But again, remember, I think it's at we need 29, so we should get an error. So yep, it says what we got returned. It says detail expected 29 features, but we only got 2. So it was handled by this validation logic. Let's test the health endpoint. So it's healthy, and then we actually have our endpoint name. And then let's enhance our validation. So in our Pydantic model, under the prediction request class, let's go ahead and paste this validator as we saw from the lesson. So it's this validator decorator. And again, remember we went over that CLS, V, and then F. V is the whole list of features. F is the single feature, and then CLS is class or self. So this is underlined right here because we need to add it to our imports. That is under Pydantic. Let's go ahead and save that. Let's test the validation. So you get a value error. So this is what we're looking for. Features must be between -1,000 and 1,000. Over here we see 10,000. Let's try changing that up. Let's see what we get. Let's do 100. Float is not iterable. All right, we don't have to dig deep into that, but the main point over here is seeing this error right here, which is what we were supposed to get. All right, let's create our LangChain tool. So we have our API URL over here, and then our fraud detection tool, pretty much the same as what we saw in the lecture. So it just checks if a financial transaction is fraudulent. Arguments, transaction data, JSON string with transaction features as a list of numbers. So here's an example. And then it will return string describing the fraud detection or fraud prediction and confidence level. We have try and accept handling, and then we actually create the tool. So we set it to the variable fraud detection tool instance. The name is fraud detection. We have the function for the tool, and then a quick description. So it checks if a financial transaction is fraudulent using machine learning. Input should be a JSON string with features key containing a list of 9 numerical values, and then returns a description of the fraud prediction with confidence level. So let's go ahead and test out the tool. So we have 29 of this list, or yeah, of this list. It says replace with actual feature values, which we will do again later with week 17, day 3's lab. See what we get as the result. Uh, All right, I see a 500 and a 500 over here, but I don't think that is. I'm going to try replacing this anyways because I see the 500, but it doesn't say down here unexpected response format. But let's just try it out. Okay, so this is what we were expected to get. No fraud detected, score of 0, and then low confidence, and then transaction appears legitimate. So again, going back to this, uh, the way I got it to work was because I saw that 500 and then I saw the error 500 right here. But I did notice it's over here it says internal server error, and then I did not see any unexpected response format, but just went ahead and go try it. I just went ahead and tried it and it worked for us. So okay, so let's continue on to part 8. Let's create an agent script. So we have our imports. We're setting our OpenAI API key. There's also so the first check we're going to do is using OpenAI, but there's also a command you can run that doesn't use it. I do have my API key, so I'll show you guys both ways. I'll delete the API key later.
So we can use the API key to see if ours is working.
Yeah, go for it if you can type that fast. All right, so we're just initializing the LLM and then creating our agent, initializing it, and testing the agent. This zero shot React description is it just so it specifies the agent type. So it'll specify an agent that reads the user question, reasons about what to do, decides whether to call a tool, uh, whether it uses the tool result and produces that final answer. So it's just for the agent type. All right, let's run the file. So most of all this text is just saying the deprecation. Because again, we installed LangChain, I think 0.1.0, the first version. So if we take a look at these first few ones, it says, where did I see that? It says unable to determine if the transaction is fraudulent due to errors with a fraud detection tool. Down here, we get something different. It says since the transaction data provided is all zeros and no fraud was detected, it is likely a legitimate transaction. So the final answer is the transaction data provided is most likely legitimate. So we got two different uh, responses, uh, both on different sides of the uh, both on different sides. So I say it's working because it did notice that all zero it was all zero. So and that was during the second iteration. Any questions? And then to test it out without OpenAI, you can run this code. So using Python, we have our imports. Then we just create a sample transaction. So this list 0 times 29. Let's go run it. So tool result, no fraud detected. Score 0, confidence low. Transaction appears legitimate. So to add some documentation, we will go into our app.py and then up here, notice how we already have a title. So SageMaker Fraud Detection API. We can also see that over here. So that kind of means we can add more to it. So, which is what we will do. So instead of just having the title, we also have a description. So this fast API service wraps a SageMaker XGBoost endpoint for fraud detection. It provides error handling, request validation, and LangChain integration. And then we have our endpoints and then some examples and the version. So let's save that. Let's refresh this and we see our documentation. So at first I thought that you could just add like a doc string all the way at the top or something and it'll show up on there, but no, you actually have to put it in within this fast API initialization. So let's actually go through and try to use our validation file from last week's day 3. All right, so what we're pretty much doing in this command, all right, let me see if I can, let me actually put it in an actual file so it's easier to see. To delete all this, I'm just pressing Control K on Mac, just deletes all the lines. Shoot, I did it in the in the wrong file. Hold on. Or wrong project, I mean. All right, so we have our imports, LangChain tool, pandas, and then JSON. Remember, pandas just allows you to work with data better. So we're loading the features from our CSV. So I'm just specifying the file path to it. And how I got this was I just went into my day 3 project and did pwd present working directory, copied that, added a / and the file name. So we're getting the first row. So column 0 is target. And then columns 1 to 30 are the features. So getting first row, and then the actual label of it, if it's normal or fraud, and then getting the rest of the features. Then we're using, we have some print statements. We're passing in the features to our test data, and then parsing with the result and returning it. So let's run this file. actually, we actually have to install pandas, I think. So we got a 422 client error. So again, remember I was telling you guys we have to change everything that it's not expecting 29 features anymore. It's expecting 30. So I'll just do Command F, find 29, place all of them to 30. That trying to see if I can forget.
I think if you hit the down arrow or
Yeah,
on the left
yeah, on the
side,
far left.
like,
Oh, okay,
yeah,
okay.
yeah, there you go.
Yep. So yeah, if
I just
say
replace all.
yeah, you can replace all.
Unless there's another 29 here somewhere. Place all will stay right. Right. There you
Okay.
go.
All right.
Unless
Now let's check, just double check. All right, there's no 29. All right.
There's still one more that it didn't find for some reason.
is it?
And the expected 29 features right there. Yeah.
Oh,
That's
okay.
weird.
Yeah. All right, save that. And then let's rerun our Python file. So there's no fraud detected over here. But now let's try to do something with fraud. So let's create another file, day3 test fraud.py. And then so we have our imports here. And then again, we're specifying where to get that CSV file. Now, instead of finding the first, uh, just the first row, it's finding where the first column is a 1. So it's finding that first row where the first column is a 1. So it'll find it and it'll use that row compared to what we had before. So let's go ahead and run this. Uh, all right, okay. All right. For this one, we have to go back to our validators and instead of messing with the length of the features, we have to mess with the individual feature itself. So instead of limiting it to between negative 1,000 and 1,000, let's increase the number. So let's try negative 20,000. Give us a big range. All right. See if 1,000 is anywhere else. I don't think it is. All right, just here. All right, now let's rerun our file. So fraud was detected this time. It found 86 fraud cases in validation set. So the result, fraud detected with medium confidence, We got a score of 0.572. The specific transaction or row we were looking at should be flagged for review. So that is the end of our lab today. Let me just go over the summary of what we learned. So we've built a production-ready fast API service that wraps our SageMaker endpoint behind a clean API, handles errors gracefully. So we looked at cold starts, timeouts, and valid input, validates requests with our Pydantic models. Again, those were those classes that are the blueprints, integrates with LangChain as a tool, and can be used with AI agents to make fraud detection decisions. This is how machine learning models are deployed in production behind APIs that other services can call. The fast API layer provides abstraction, error handling, and integration capabilities that direct endpoint calls don't have. Are there any questions? Let me stop the recording.